content-based filtering or versus collaborative filtering. So let's try to understand what each content-based recommendation system, and what each collaborative collaborative based recommendation system. Let's see. So first, let's try to understand the what is collaborative filtering. What is this thing? First, try to understand it. So that collaborative filtering, collaborative filtering. Okay, let's see it first. So collaborative filtering, let's try to understand these things through an example. Will better. So suppose let's take a user. Suppose let's take we will denote simple user by the symbol UIs, and the corresponding item means, in previous lecture we see item means it will be a video, or it will be a product, or it will be a movie, like kind of things. Let's we call it an IJ. So suppose let's take a user U1. Suppose in these examples we will consider the movie examples to elaborate these discussions. Okay, suppose let the user U1 like these movies. Movies, I am using item here. Instead of using item, I am using here movie examples, and we denoted this movie by simple MJ. Okay, so suppose let user 1 like these movies, M1, M2, M3. These three movies user 1 has liked. Okay, now another users U2, suppose let he likes these movies, M1, M3, M4. These three movies are liked by user 2. Now our job is we have to, using this based informations, using the informations of user and user 2, we have to see what kind of movie user is possible chance, what kind of movies are user 3 will be liked. Okay, so suppose let's take user 3 already liked M1 movie, and now we have to find, now our task is we have to find, so what kind of movie user 3 will be liked, what kind of movie. So based on these two informations of user 1 and user 2, okay, so if you just see this thing, here, user 1 liked M1 movie, M2, M3, and user 2 will like M1, M3, M4. So the common movie that they have liked here, M1, M1, and for both the three cases, M1 is common movie, means M1 related content, M1 related content, 3 user has already liked. Now let's see what are the movies the user 1 and 2 are liked. Common movie, what are the common? So M3 is liked by user 1, similarly M3 also liked by user 2. So now there have be a chance, since user 1 and 2 have already liked M1, and user 3 also liked M1 movie. So based on this history, so we can conclude that since user 1 and user 2 already liked M3 movie, there may be a chance user 3 liked M3 movie. So we can recommend this movie to the user 3. So these kind of systems are called the collaborative filtering. Collaborative means we have used the informations, we are building such algorithms that are collaborative to each other. So we have find the these are the collaborative to each other. Okay, it's based on the previous customer's experience, based on the past customer history, and we will try to match some things related to that past customer, and based on their experiments we have recommended some things to the new customer. Okay, you can treat this thing, you can treat this user 3 as a new customer. Customer. Okay. Let's take customer. Okay, and user 2, U1 and 2, you can call it the old customer. Okay, that's the thing that means based on the experience of the old customer, we have to recommend something to the new customer. Means based on some common features. That's the here. Based on some common feature. Okay, that's the thing that actually called the collaborative filtering. So the core idea, so behind the collaborative filtering, the core idea is, so the core idea here is a user who agreed in the past also be agreed in the future. That's the main core idea. So the users who agreed in the past, so the tent that they also may agree in the future. This tend to also agree in the future. Okay, that's the main core idea behind the collaborative filtering. I think you got the idea how this means. By simply using the collaborations, we are doing the recommendation system. That's the simple thing. Okay, that's because of that collaborations we called these things as a collaborating filtering. Okay, now let's try to understand what is content based filtering. What is content based? Content based filtering. Okay, that's the thing that we have to. So first thing that we have to remember in content based filtering, in the we have not used the informations of the edge customer. So if you just remember the past, you remember just previous lecture, if you remember, we have built the size of our data sets is like that. It's a matrix type of data set. In row, we have used a user. In each row, we have used the user, and each column we have used the each item. Okay, that's thing we have used. And the informations that the each cell here contain the informations of the each user corresponding to a particular item. Okay, that's the AIJ. Since this AIJ actually is the informations for a user and for a particular item on corresponding on that user. So that's things already we have seen. So now the first thing that we have to in our mind in the content based filtering, we have not used these informations. We don't used. Yeah, we does not use the AIJ information. Okay, that's the first thing that we have always in our mind. Okay, now to represent this matrix, actually we need two items, ui and item j. Suppose let's take, instead of the same examples that we have discussed in this collaborative filtering, the same examples also I will use to discuss the content based filter. Suppose let's take the we have taken here the movie example. Suppose like a movie mj. Okay, so in this movie there have some features we have already known, because age movie there have some features. So it may be action, the features is action movie, or maybe it may be dramatical movie, drama, or it may be a 90s movie, or it may be a actors. There have some the actors of the age movie, it's also very important features. So what kind of actors there have? Actor 1 or actor 2, who is the director of the movie, directors, and what is kind of story, what type of story it is. So like this kind of thing we have. These are the features for age movie. It may be actions, or it may be romantic, or maybe a dramatical movie, or in which years that movie has launched, is 90s movies or past 90s, something like. Who are the actors on that movie, and who is the directors on that movie. These are the main features of the age movie. These are called the features. These are the features of age movie. Okay, now actually in the movie we have seen also, yeah, we also, they are have some features also as users. They are have independent choice. As user can be choice a romantic movie, and one users can be choice a dramatical movie, one users can be choices horror movie. So it's depend on the users to users. Okay, so they are have some choices also as users. So the like, which kind of likes, like which kind of, suppose like he likes action movie, suppose let he likes action movie, suppose like he also like a romantic movie, maybe liked romantic movie. So its gender is also male matter in such users. So the choice of the gender, and it depends on the choice of or which kind of movie they can love. So gender is also a one of the factor. And age, which kind of age? If it's a kids, it's below 15 years, it may be like a cartoon kind of movie. If it is a middle aged, then he may not be, he may like some different kind of movie. Okay, if it is some students, in background, some engineering background, he may be like some science fiction movie. So such kind of things means also depend on the education level. Such kind of actually features also, and it is. So such kind of features also depends on to choosing a movie. So these are the features of each customer. Features of each customer. Okay. So now the after finding the features for each users as well as for each movie, now we have to do the next thing. This thing, we have to find the features vector for items as well as for age users. So actually we have using the movie. Actually this one is the same as the item j. If we in generally common, this is the item j. Item. Just in these examples, I am using this movies concept. So now let how to convert these features to a vector, because at the end of the day we have to make a mathematical calculations. So in such scenario, to make a calculations, we need a vector representations of each movie and also age users. Then only we can use the mathematical formulations. So now the question is how to convert these features to a mathematical vector. Is a vector format. So this is the features transformations coming to our picture. Suppose let's take the movie J. We have taken as item movie J. We have to convert these movies to a features. So by the simple features transformations here, generally that they have various technique we will see in next videos. but in general the features transformations are look like this type. These are the features, supposedly. These are the features of each movie. So the first feature component is the action movie. Is a action movie. The first features maybe like, if yes, we have right here 1, otherwise we have noted here 0. Okay, that's maybe one feature. There have maybe a chance that it's what each are the actors of the actors. These are the actor. Okay, actors. Which actors they have. So suppose if we using the vector as a binary representations, and since zero and ones combinations of 0 and 1, then we have to consider edge features. So in a movie there have lot of features. Okay, so suppose it's actor 1 or not. If yes, we have used 1, either 0. So this the next feature, it may be the next feature is actor 2 or not. If yes, we use your, is this movie a romantic movie or not, like this kind of features we have to use. So these features may be which are the which decades the movie was released, in which decades, in which decades this movie is released. It may be 19, or it may be 2000s, or it may be something, means these are the mainly features. Okay, by the considerable, we have considerable all the features, we can easily convert each movie like a features vector. So it will be like this type of vectors. This type of here 1 0 1 1 1 0 0 0 1 0 1 1 0, like 1. These kind of features vectors we can convert. Okay, these are the called the features of these are the features vector. These things are called the features vector of a movie MJ. Same thing, same kind of concept also applicable on the users, for each users. Suppose let the user is, we have taken here UI. Okay, these are the actually means that for users, what will be the what kind of features they have. So it may be a gender, if it may be male or female, that's also great features. What is its age group, that's one feature. What is its locations, also depends on the locations. What is its educational background, what is its educational background, what is a likes, what is he likes action movie or horror movie, like this kind of thing. Actually we have to use what is likes, and means another one, it may be what is kind of actors they have, like actors, which actors they have mostly like. So these are the main features of the each users. Also they are possible to many features for the single users. Okay, so the samples thing, if it is gender, if it is a male, then we have used 1, either 0. If what is its age group, so if it is on this age group, then 1 or 0. Actually it's depend on our how will feature these factors to a features. If we represent these binary representations, they are then for each features we have to take into our considerations. If we have not interest to represent is a binary, just simple we have taken here the numerical quantities means 2.5, 3.5 means like that. I'm talking about like this type of features. Numericals, categoricals means there have another chapter, features transformations. We will see these things in a later chapter, but means they are this kind of vectors actually we can got. If we 4.5, it may be 3, it may be 2, some numerical value, it may be some categorical data m or f, it may be some horror, it may be some value also here also some got value 3.5. Yes, some this kind of representations also possibles. These things are actually called the binary features vector. These things are called actually binary. Okay? These are the mixed feature vector, mixed feature vectors of the user UI. These are the mixed feature type, and this is the binary type. So it depends on our means problem to problem, situation to situations. So these things actually it's the chapter on comes from the features transformation chapter. We'll see these things, how to convert these features to a. But the main challenging part is to collect the features, all the features to into our consideration. This is the most challenging part here, to convert is movies and items, is users and items to a features. Most challenging part is to collect, to consider all the factors into our calculations. That's the so the features that we have gathered. For large features, the dimension of our features vector must be a large vectors. So in such scenario, the time complexity increased. So we will see these things, how to control this thing. We'll see in the next video. But now the main motto of here of these discussions is to understand the content based filtering and collaborative based filtering. What is these things? Okay. Now we can easily convert this thing as a features vector. Now after converting these things, we have to simply use this. We have to simply use these features like transformations into our calculation. So these transformations, here it is our output, means here it will be our yi, and in this scenario we will use the xi, these things xi, and in this xi we have two type of things. First one is the user, this vector is responsible for the first part of this, is responsible for ui, and the second part will be responsible for the, this is simply u1, u2, u3. Like if we have if we have suppose s feature, m features for m user. Okay, so this is the features vector. This is the features vectors for a user, for a user ui, and these things, this site and this site is a this is item for item 1, item 2, features for the items. These are the features actually. Suppose let we have n features for item. So this is the features vector for, these are the features vectors for a for a movie, for an item ij. Okay, these are the simple representations of the features of each features into a vector format. These are means the job we have to convert, and if we convert these things, then corresponding we have a value from this matrix, we have a value for this from this matrix. Now we will using this simple value here, it will be a, I'm using a different color for, here we are using the aij. Okay, these are the sample using as a yi. Now if we use these things, these are the same thing of the classifications or regressions problem. If this ai value is a integer, if this value is belongs to the integer value, then so we have to use a classification problem. We will use a classification problem. If it is a belongs a real number, then we will use a regression problem. Regression problem. But I am not going to discuss, because in supervised learning model we have already learned how to calculate a classifications problem and regressions problem. So I am not going to discuss this content based clustering, content based content based filtering. We have not discussed, because in classifications of regression problem we have already seen this concept, or we have already learn how to do the classifications and regressions problem by simple converting. The main challenging part is how to convert the each items to a features. We will see these things in the features transformation chapter. But in this chapter, recommendation system and magnifications, mainly we focused on this collaborative filtering. We mainly focused on this collaborative filtering. This is the main task here, mainly focused on. We have to focus on this. So in this chapter, we will mainly focus on this collaborative filtering concept. Okay. So this is the means content based filtering. Actually, if you see the content based filtering, actually a regressions, one kind of regressions and classification type problem. It is a regression or a classification type problem, or a classification problem. Because in supervised learning model series we have already learned, so I am not going to discuss these things now. In this series we have discussed, we will learn a collaborative filtering. Mainly we will focus on this by simply using these simple collaborations, how will recommend something to a new customer. That's the main job here, that's the main task here, to build a collaborative filtering class. So the idea is based on the users that agree in the past, that it's also may agree in the futures. That's the main core idea in this lecture. So we'll see these things in next lecture, next video, how to develop such kind of collaborative filtering. Okay, we'll see this thing.